to part B of solving polynomial equations and inequalities. And part B is where we're going to be focused on inequalities, okay? We're going to be using decimals to solve the inequalities. So you want to make sure that the right side of the inequality is equal to 0. You're going to graph the left side of the inequality. You're going to look at the inequality symbol if it's greater than. So remember, if it's greater than or greater than or equal to, we're going to pay attention to that. We're going to be looking at the graph for when the function is above 0. If it's less than, which is the one that looks like an L, less than or equal to, we're going to look at the graph and the function is below the 0. Then we're going to write the solution in interval and inequality notation. All right, so let's dive in. All right, so up first, we have x times x plus 3 squared times x minus 4 is less than 0. We know that this is less than. Okay, so we're looking for when is it less than 0. When we said less than means that we're looking for when is it below the x-axis. Okay, so we're looking for below the x-axis. Let's see. So when we're below the x-axis is what we're highlighting. I don't know, my highlighter is going to be so giant, but it is, okay? We're going to just roll with it. Let me see if I can use this one and it not be so giant. Okay, they're all going to be giant. Let me see if I can make them not giant. Yeah, there we go. We're going to minimize it a little bit because I need it, but I don't need it to be that big. So we're looking for below the x-axis. So we're below the x-axis from here. That was just the coloring of it. That's funny. Oh, probably should change the size of it, not the color of it. The color was fine. My bad, bro. So let's try that again. So below the x-axis. So there we are. That's all we're analyzing because it says less than. When is it less than? It doesn't say when it's equal to. It just says when is it less than. So we're going to look and say, okay, well, it's less than from where to where? Well, it starts here at 0. Right? So it starts at 0. And then it stops at 4. And stops at 4. So this happens when x is greater than 0 but less than 4. This is what it means to write it as an inequality. So this is it written as an inequality. In set notation, we would say x is from 0 to 4. Okay? Notice that I'm using parentheses. You're going to use parentheses when you have strictly less than or strictly greater than. So these were strictly less than and not equal to. When they're equal to, that's when we use the bracket. Think about the bracket has the horizontal lines on it, right? So answer is simply from when x is greater than 0 but less than 4. That's when this is a true statement, and that's all you have to do. Okay? Now let's do it from the start where we have to make sure one side is equal to 0, and we're going to use decimals to graph. All right. So starting here, we have 2x to the 4th is greater than 3x cubed plus 9x squared. I like to just keep it simple and move everything from the right side. I don't care how many terms are on there. I'm just going to make my right side equal to 0. In reality, it doesn't really make that big of a difference. It just helps you eliminate a step in the end. So we're going to subtract 3x squared. Let me make this guy a little skinnier too. So we're going to subtract 3x cubed, and we're going to subtract 9x squared. I realize I said 3x squared. And so now we are working with first getting one side to 0. So we have 2x to the 4th minus 3x to the 3rd minus 9x squared is greater than 0. Okay, step 2 is to determine, are we looking at above or below the x-axis? So because it's greater than, that means that we're going to be looking at above the x-axis. Okay, so we're going to be looking above the x-axis. Now we're going to go ahead and graph, and we're going to look and see when is it above the x-axis. All right. So I'm going to go to Desmos, and I'm going to type in 2x to the fourth minus 3x to the third minus 9x squared. And hopefully I remember this as I proceed to go to Desmos. We're going to see if I do. All right. So here's our Desmos. It's going to open. And so we have 2x to the fourth minus 3x to the third minus 9x squared. Okay? Simple enough, right? So now when we look here, we're looking for when does this function is above the x-axis, because it said it's greater than. So we're above the x-axis from here, and we're above the x-axis here. All right, in the middle, we're not. So we're only focusing here. If you're going forever to the left, that's going to be your negative infinity. If you're going forever to the right, that's going to be your positive infinity, right? Let me make her a little skinnier. Okay, so when we are looking at this guy and this guy, we're going to write their bounds. So this one starts here. And if you can't tell what the value is, you're going to go. And we're going to click here. And it's going to tell us what that value is. So it starts here at negative 1.5. And I'm just going to click it so I can highlight it. And then I'm going to click here so I can highlight it. And at 3. So those are my zeros at negative 1.5 and 3. So my bounds are, this is a true statement, when x is going to the left is less than negative 1.5, right? And when x is greater than 3. So that's written as an inequality, all right? It's a split. There's a pause in between. These are not connected. So it would be this and this, right? Now, when we are writing it as a set, we want to write it using our parentheses and brackets. So using parentheses and brackets, we are going from the left, which is negative infinity, all the way up to negative 1.5. And that's a U. It's a weird looking U, but it's a U. Let me see if I can make it a little curve. And then we start again from 3 to positive infinity. So this is it as an inequality, and then this is it in set notation. We need to be able to read both and write both. All right? Okay. Let's get back to the other notes. I'm going to refresh so that this will go ahead and be cleared so that when I come back. All right, so we ended up with, after reading our graph, we ended up with the solution of above the x-axis. It was above the x-axis from negative infinity up until negative 1.5. And again from 3 to positive infinity. This means that x is less than negative 1.5. And x is greater than 3 are our possible solutions. All right. So this example, this is where you do. So I want you to pause, and you're going to pause and then come back, and we're going to see how you do. Remember, the goal is first to get one side equal to 0, and then after you get that one side equal to 0, you're going to proceed to graph. Okay, welcome back. So, when you started, it said here, you want to make sure you get it into standard form before solving by graphing, right? So, in order to get this one side equal to 0, we're going to go ahead and distribute that 4. So, that gave us x to the third plus x squared is less than or equal to 4x plus 4, right? And then the second thing you should have did was now make one side equal to 0. So we're going to subtract 4x and subtract 4. And that's going to leave us with x cubed plus x squared minus 4x minus 4 is less than or equal to 0. Now the next thing we're going to do is go ahead and graph this. When we graph this, we're looking for what? Well, what is our inequality? Our inequality is less than or equal to. So we're looking for two things now. If it's less than or equal to, we're looking for when is it below the x-axis and the x-intercepts. Okay, that's what the equal to is telling us. Because of the equal piece, we're looking for when is it below the x-axis, and we're looking for our x-intercepts because that's where our solutions lie. All right, and we're going to find those solutions and then come back and we're going to write those solutions. Okay. All right, let's go. Hopefully I remember it. X cubed, x squared, 4. Okay. So we're going to type her in. We have x cubed, arrow over, plus x squared minus 4x minus 4. Okay, and we told ourselves that because we were looking for less than or equal to, we're looking for when is this function above the x-axis, below the x-axis and our x-intercepts. So I'm going to zoom in a little bit for us. I can clearly see there is an x-intercept, so I'm going to save her and I'm going to let it be labeled. There's another x-intercept. I'm going to save it and let it be labeled. And there's another x-intercept. I'm going to save it and let it be labeled. Okay, so now we have our x-intercepts, and again, because we're less than, we're looking for when is it below the x-axis, right? So I'm below the x-axis here. I'm below the x-axis all in here, and that's it. So now when I'm writing, I'm going to start off as writing it as an inequality so you can understand where we're at. So x is the x's that will satisfy this is when x is less than -2, because it's going forever to the left, right? And then on this side, the x's that satisfy this, less than or equal to, is going to be between -1 and +2. So between -1 and +2. So x has to be greater than or equal to -1, but less than or equal to +2. And those are where my solutions lie, right? So my solutions in inequality form are like this. When we take the inequalities and turn them into set notation, x is less than or equal to -2 means that you're going all the way to -infinity and then you're stopping at -2. Because it's equal to, we use a bracket, all right? On here, it's meaning that we start at -1, we stop at +2, and because they're equal to, we're using a bracket. So this would be what our intercepts would look like. And all it comes from is making sure you get one side to 0 and then analyzing above or below and finding x-intercepts. Pretty easy, right? So let's go back and write our answers. Let me turn off that. Okay, so we ended up with x being less than -2. Correct, which meant that as an inequality, that's an inequality, less than or equal to, sorry. So that means from -infinity into -2, but with a bracket because it's equal to. And then we had x is, I'm going to write it on the other side to give myself a little more room. We had that x is, it's in between, it's less than or equal to, less than or equal to. And we were at -1.5. all the way up into +2. That's the inequality, right? That's the inequality. And then writing it in set would put us from -1.5 to +2. Was it -1.5 or positive? Let me go back and look. My brain is playing tricks on me. -1. It's not even a 0.5. 0.5 was from the last problem. I knew something was off. You see nothing. So making sure you were paying attention. Okay. And that's it. That's all we gotta do. Hopefully this is doable and you feel fairly confident. If you have any questions, please let me know.